Hello, this is Vandoros Tsimpoukis, and this is the screencast for the kNN neighbors algorithm, part of my assignment 2 with Nikolaos, Vandoros, and myself. First of all, we start with we create 4 variables, cluster 1, 2, 3, and 4, which will be used to display the number of elements of the new test set that will be placed in each cluster, as each one was defined in the previous section. First of all, we start with the creation of a new array list called test times. It's the principle is the same as with the times array list in the first part. It's an array list that contains all the all the different states, the time values, and we create again, as in the previous section, we create 4 test objects array lists, which will contain the states that will be placed in each cluster. We also create another array list called distance table, and it will contain the distances from all the original set values with regards to the new values, to the new test set. Here we implement the loop. First of all, we set the outer loop contains, we want to parse, if I may say, all the elements of the original test set. And here we, originally this is the initialization of the distance table array list. The outer loop of the calculation, of the main calculation, consists of the test times, which is the new set times size. We start with set the number 5 as the nearest neighbor's parameter. We start. Then we continue with the inner loop contains the original test set dimensions, because we want to parse all the elements and find each state's distance to this to the new test sets. And the implementation is done as follows. We add a number of substations loops so that we can parse all the angles and voltages easily. It's the same principle as in the previous section. And here we see the difference in the distance calculation, where we have previous set voltages minus test sets minus original sets voltages squared, plus angles plus new angles minus original sets angles squared, and this is and here we do the square root. Then I forgot to mention the distance table is in principle an array in principle a 2-dimensional table with 3 columns. The first column will have the time values of the original test set. It has the dimensions of the original set. The second one is the distance to each of the new ones. And the third one will have the cluster that each of the original states as it was done previously. Then we use a quick sort sorter, as can be seen here. The principle is well known. To find the nearest neighbors, and then we call the getClusters method. this one is implemented. Hang on. Here we see it gets the distance table as an argument, as well as the nearest neighbor parameter, which of course we said was 5, and it will return an array which will have 5 elements. The first 4 elements will represent the number of instances of each cluster in the 5 nearest neighbor, in the 5 nearest neighbors, and yes, in the 4 clusters. I'm sorry, yeah, in the 4 clusters, and the 5th element will represent if there's any equality in the number of instances that some clusters appear. If we have, for example, 2 at the clusters 1 and 2 at the clusters 2, as we can see here, the method will return as the 5th element the value 1, which we will use as we go back to the main method to increase the kNN number, which means we will now take one more neighbor, and so on. There you have it. If clusters, the 5th element of the parameter of the array that's returned from the method is 1. See, kNN plus plus, and we repeat. We have an non-ending loop which will break only when everything is parsed. So now we go to the actual classifications. If the elements, if the array that we have the 4 numbers, so that we don't always use the array parameters, and which means if cluster 1, which means the instances in the nearest neighbors of cluster 1 are bigger than cluster 2, and of cluster 3 and of cluster 4, we classify this value as we cluster this value in cluster 1. See, we put it in the array list, and as we can see, I run the program. There we go. We have the 20 states in the new test set, and the program prints in which cluster it belongs and which state it actually represents. High load rate during peak hours, low load rate during night, disconnection of a line for maintenance, or shutdown of generators for maintenance. Thank you very much. I hope you'll like it.